So in this video we are going to introduce some network measures, the basic ones. We are going to see how to define them and how to compute. And for computing them and using the results, we are going to use Gephi, which is the software that we have already introduced in the previous video. So this is the general overview of Gephi, where we have on the left we will have some windows where we can see the appearance and the distribution of the network. In the middle we are going to see the representation, and on the right we have the statistics that we are going to compute. So this is the initial setting that we are going to see when we are opening Gephi. It was worth to be mentioned that we are going to consider that we are referring to networks and graphs for the same type of structures, right? But in the sequel, since we are going to be more focused on the computation of measures and the properties of the graph from the single nodes and edges, we are going to call them better networks than graphs. So for doing the calculations, we are going to simplify them with the Zachary-Karate Club network, which is already loaded in Gephi. So when you open Gephi, you have access to this network. You can load it, and you will see that it has 34 nodes and 78 edges. In this case, it's introduced with just a pair of edges in one sense or in one direction. So we have 2, 1, and not only 2, 1 and 1, 2. So in order to have both pairs, we have to say that it's non-directed. So once we accept, what we have is this representation, where the network is in the middle. So what we see is that we have some statistics that we can compute, some measures, right? And also it can see, if you go to the top of the window, you can see that there are many windows that you can see. So for returning to this, you can go to the window which is called appearance or overview of the network, where you can see in general what is this overview, but also you can have access to independent windows as you have. So introducing the measures, we're going to start with the first one, with it is the average degree. Given an undirected network with 10 nodes, we understand that the average degree is denoted by a k between angles is the average of the degrees of the nodes in the network. It also be computed looking that this is equal to the sum of nodes of the network of the degrees as 2 times the number of edges divided by n. So it's the total sum of degrees divided by the number of nodes. It should be noted that this information is just to reduce the properties of the degrees to single number. To have a better overview of the network, it's better to join them with an analysis of the frequencies of the degrees of the network. So it's good that we include a representation where we can see how they are distributed. It's also worth to mention that we are going to see it works when we are working with directed networks, and in this case what we will have is that the average degree has to be separated for the n degree and out degree, and it's just the number of edges divided by n. So once we go to this window, if we press the first option in a statistics window, grado medio average degree, what we have is we have access to this degree report. So the average degree in this case is 4.588, and later we can see a representation where we have the degree distribution. With the value in the x-axis, what we have indicates the value of the degree, and count indicates the frequency. So we can see, if we read from the left to the right, the pointing 1, 1 means that we have one node of degree 1. The point 211 represents that we have 11 nodes of degree 2, and so on, until we arrive to 16.1, which represents one node of degree 16, and 71, which represents just a single node of degree with degree 17. The same that we have done for the average degree, we can compute with the average weighted degree. But the thing is that this has to be considered when we are considering networks where we have weights on the edges. So in this case, for computing the degree of a node, it has to be computed with the sum of the weights of the edges that are adjacent to each node. In the trivial case that we have that no weights assigned, so we will have to assign one and it coincides with the degree. So with this new definition, we can compute the average weighted degree of the network in a similar way as we have done just with the average degree. Other measures that we can introduce on the network are the diameter of the network, and this has to be considered when we have a connected network, a network with a single connected component. So for doing this, we first have compute the distance from ij, denoted dij, which is the distance by the shortest path between nodes vi and bj. So once we have calculated this distance for any pair of the nodes of the network, the diameter is the maximum of this quantity. So the maximum distance between two nodes in the network whenever we are always using shortest path. So the thing is, another related to this, we have other measures. So we have the eccentricity of a node, which is the distance of a node to the farthest one from it, and also the radio of a network, which is the smallest value of the network eccentricities. So this permits us to locate a node that is less distant from its farthest node. So these measures, what we can do is we can compute them when we are seeing the third option, which is the diameter of the network. So computing this, what we can see is that we can compute the distances, right? And we can also see other, so in this case, we see that the first two results are the diameter that we have already seen, the radius, and the average path length, which is the average between all the shortest path in the network. What we see is that the diameter is 5 and the radius is 3. So this represents us that the most center node in the node is a distance 3 at most of the farthest nodes, and the biggest distance between two nodes is 5. Also, the average path length means that in general, we can connect two nodes with between 2 and 3 edges on the network. More measures that we can consider the density. So given a connected network, the density of the network is the percentage of existing nodes respect to the total. It means what is the percentage of nodes, of edges that we have in our network respect to a complete network where we'll have all possible edges. And so the thing is that we can see how this can be computed, and for obtaining the results of the density, what we can go to the fourth option, which is density of the network, and when we compute it, we see that the density is, in this case, is 0.39, which is a quite low value. So the thing is that there are not so many connections. So once we have computed this, we can go to the left panel and we can try to depict or to use the information of the degrees for obtaining a better representation of the network. So if we choose to color the nodes according to the degree, so we can see that we select the option in appearance, apariencia, we choose nodes, we say ranking, and the ranking we choose the option degree or grado, and here we have some colors. So the thing is, the darkest color represents the ones with highest degree, and the clearest color represents the ones with lowest degree. So once we apply, we obtain this representation that we have here. Using also the degree for improving the representation, we can also use to choose the second option where you have some circles to the right of the palette, and to use this as a ranking. So when using this as a ranking for the nodes, what we have is we are going to work with the size. So the minimum size, if this is 10 and the maximum is 40, that we can vary. So if we apply what we have this representation, we are representing biggest nodes for nodes with highest degree, and smaller nodes with the ones with lowest degree. Just to complete this representation, it will be interesting if we can add some labels to the nodes. So if we go to the bottom, to the small symbol on the right of the center panel, so we can see the several options that we can use to include labels. So if we say the third option, etiquetas or labels, we can choose to appear them in nodes, and now pressing this, we can make them here appear the number of nodes. So with this, you can also work with properties about the edges, nodes, types of fonts and representation, and improving and to work with this in the network that you have. So with this, we have introduced in this video how to work with the degrees in Gephi and how to use them for improving the representation of the networks.